In this short video, we discuss the process of finding the derivative of a function. Well, let's look at the red curve as a graph of a function f of x, and we ask to find the derivative of this function at the green point a. As we know that finding the derivative is finding the slope of the tangent line at a. So we start this process by picking a point on the graph, let's say b. Notice that the horizontal distance between a and b is h. So we move point b closer to a, and as we see that the distance h gets closer to 0. To some point when h is almost zero, the secant line AB looks almost the same as the tangent line at A. So the process of reducing the distance of h or taking h to 0 is called the limit process. And we use a limit process to estimate the slope of the tangent line, which is estimating the derivative of a function at a point or finding the derivative function. So the derivative of a function exists when this limit exists. And we notice that this function here is the formula of finding the slope of the secant line that goes through the 2 points x, f of x, x plus h, f of x plus h. And h is actually the horizontal distance between these 2 points. To denote the derivative of f of x, we can use different notations. You can use f prime of x, you can use d over dx of f of x, y prime of x, dy dx, big D f of x, or big D sub x f of x. So now, let's look at an example. Let f of x be equals to x squared, a parabola. Can we find f prime of x? So to find the derivative of functions, we want to use a limit process. And in the limit formula, we have f of x plus h, and we have f of x. So we would like to determine the formula for these two expressions. In this case, f of x plus h is x plus h squared, and f of x is just f of x, which is x squared. And we put everything into the limit formula. We have a limit problem. And the next step of finding these limits is, you always want to see if you can use direct substitution. In this case, you can't because you have h is in the denominator. Can't plug 0 into the denominator. So we will have to distribute the x plus h squared out into x squared plus 2xh plus h squared. And you see that you can simplify the x squared and this x squared. Well, what left over will be 2xh plus h squared divided by h. And we can factor the h out in the numerator. And once you factor it out, you can cancel that h to the h in the denominator. Now, the h in the denominator is canceled. We can plug 0 into the h to find our limit. And 2x is what's left, which is the derivative of the function x squared. We just have done a problem of using the limit process to find the derivative of a function.